We just want to give you a case of a short presentation. Otherwise, we can talk for 2 or 3 weeks, but we'll just try to give you an idea of what can be achieved, what type of methodologies there are, and its application in various industries. I'll start going through this quick presentation. We have a tradition in Australia, and it's the same here. We are grateful for the owners of this land that they allowed us to be present here and to use this facility. This is a brief summary of the presentation. I'll explain in few words what does Antigona do, what are our experiences and credentials, the services that we can offer, the methodologies, the types of methodologies, and then we'll open for discussion and question. I have to bend, sorry. So this little company was established back in 2004 and exclusively has works like assisting contractors, assisting authorities. It provides consulting, design during pipeline installation, communication installations, and as I said before in the speech, it has got application into a lot of infrastructure areas and the mining areas. This down here is a project from very long time ago. I'll address it later on, but this is the typical HDD setup for a shore approach, but I'll address it in more detail further down. The company specializes in contracts and project management, site supervision. We can do analysis and evaluation of the potential. We can do estimation, cost analysis, methodology recommendation, certain objectives and implementation, and attaining implementation of long-term plans, business development, and as I said, our clients are contractors, consultants, state and federal, road, railway, water authorities and agencies. Even though the industry is big in Australia, all these entities that you see at the bottom line there, the knowledge is quite limited, and it requires constant updating, and so the big consultants usually go to the smaller consultants such as us that we specialize in this area, and we together with them, because they've got the authorities, they've got the relationships. It's a specialized type of consulting to determine the size, the diameter, the length, and the type of methodology that can be applied on any specific project. Depending on who you talk to, there's no specific standard, but these are the types of methodologies that are most common in Australia and throughout the world. The simplest of all is auger or truss boring. Then we have microtunneling / pipe jacking. We have horizontal directional drilling. Pipe rehabilitation is something that I think will be quite applicable for the streets of Port Moresby. Pipe ramming was an early methodology that is not that often applied lately. I decided to put here an example of launch and retrieval steel segmental shafts, which can be used as the word implies, to launch the microtunneling machine and to retrieve it from the other end, and then it can serve as a shoring system while you're building the manhole. But there's plenty of photos down there. I believe photos replace 1,000 words, so it will be clear once you just go through it. When I was driving on the Cocky 2-mile road last year, I noticed an example, and Murphy here is telling me that case is being potentially closed now. But I want to explain to you, I use that as an example of what can happen, and unless the service, the stormwater pipe is repaired, and it can be repaired by trenchless methodologies, because that specific case was quite a complex for it to be repaired with, you know, standard excavation, cut and excavation methodologies. I'll provide a few useful links, and I believe all young engineers should get interested in this, because this is a niche area. Not many people in Australia know this, and it's quite exciting. It can do things that at the moment is hard to imagine. I struggle to keep up with the advancement. Later on, Tony will explain some of the advantages about HDD. These methodologies, not one company specializes in all of them. So if somebody does auger and boring and microtunneling, they don't do HDD. There have been examples of people trying to do that. They don't work together. You know, it would be ideal, but I'm yet to come at a contractor that does both of those. This here is a typical drawing of a design of a trenchless application. You can see here, this is the road, and basically you have to install this pipe. The way it's done, I'm going to be trying to be very simplistic, and at the end of the presentation, if there's any questions that you can ask me and Tony will answer. If something is not clear during the presentation, feel free to jump in. But basically, a typical design engineer will give you this type of drawing, on the basis of which the contractor will price it. So you'll have the length, and this is the launch pit, this is the retrieval pit here, and they'll tell you what the casing is here, the way that you do the spacing, the protection of the carrier pipe. So the process methodology you have, you drill the bore from A to B, and most of the time, 90% of the time, the bore is cased, so there's no chance of the road to collapse or anything like that. When I say cased, that means that the drilling is done, and simultaneously you have a steel casing being installed. So based on this, the micro-tunneling pipe jacking contractors will get this, and there's 5, 10, 20 crossings in a project, and they'll price them. I don't have to, but I will. I'm pretty sure you all understand that the geotechnical information provided as part of the tender process is crucial. So the less geotech information you have, the riskier it gets for the owner of the facility, of the asset. So and it's not just any geotechnical information that is needed. You need to do the geotechnical bore at least to the inlet level of the pipe. You need to understand where is the water level. If there is water level, you need to determine whether that's water level based on rainflow, or is it, you know, water level that's there. You need to determine the abrasivity of the rock, the strength of the rock. There are standards and specifications which nominate what the geotech report needs to have. This is your typical auger boring machine. Yeah, okay. It's all right. Yeah. So this is your typical auger boring setting up, and this is what I said. So this is your auger borer. This is the augers that go inside the casing, and the next basically slide explains it. So you've got a cutting head here at the front, and the earth that's been excavated at the you know, drill face gets transferred back through the casing with augers that are tied to each other, and then it's basically comes out of the auger machine. And it's one of the most simplest of methodologies. You can't steer this method, so you rely on the experience of the operator, and usually it's applicable for water pipelines where the precision, you can come out 200, 300 millimeters left, right, and it's only good up to, let's say, 50, 60 meters. Depending on the experience of the contractor, they can go more. But that's your typical auger boring method. Each of these methodologies has got its own advantages and disadvantages. Like I said here, auger boring is cheaper because the methodology that you use to extract the material from the head of the bore is basically augers, and then it comes into the pit, you pick it up with an excavator, off it goes. The next methodology is, let's say, vacuum, and you need to have a vacuum track on site all the time, but it will come in the next slide. The disadvantages is that it's not as accurate. It can't go in very, very hard soil. It can only go to 20 MPa UCS, and as I said, the bore length is limited to about 60 meters. Whenever something goes beyond 60 meters, we try to price it as a guided bore, which will give you certainty where the bore will exit, come out. Again, I've put here, the second one is microtunneling or pipe jacking. This is a methodology which is laser guided. Basically, you have a laser at the back of the pit, and I'll just show that here. So this is your typical vacuum extraction laser guided boring machine. Somewhere here at the back, there's a laser that goes through the head, and there's a camera at the front. And a good operator will get a precision of plus minus 5 millimeters over 100, 200 meters. This is very much utilized in Australia, in particular for deep sewers, and where the difference between the starting and the end invert level is quite basically limited. So if you've got, I don't know, 100 mil from 1 kilometer for 1 kilometer sewer to be installed, it's very crucial that you achieve that precision. This methodology can go up to 150, 200 meters, and using the humble pipeline laser. There are more complex machines, which I'll show a little bit later, that can go kilometer, 2, 3. On a mining project in Papua New Guinea, there was a 4.2 kilometer of microtunnel done. But that is a complex machine that uses complex survey methodologies, and there is simply no time in this short time to explain it in detail. This is on the right side here is your typical, what we call pipe jacking machine. The yellow is the frame, and this front end is, we call the shield. Depending on the ground condition, as you can see, this one is for rock. It's got rock cutting discs on it, and this methodology is utilized for diameters above 1.2 meters. This one here, the vacuum laser guided extraction methodology, goes up to 900 millimeters, because after 900 millimeters, the diameter and the amount of dirt that comes, you need an extremely powerful vac machine. So this pipe goes into a vac track. So once the vac track is full, you pause the operation until he goes and so the bigger the diameter, the quicker it fills the truck, but you need a lot of power. Also, the power is needed depending on if this is 10 meters deep, so you have to be able to extract 10 meters of depth of power of dirt to the surface. So it's very every job is specific. You need to get somebody that knows about that technology to look, to consult, and to advise for the best choice. This is a project that was done for a company called Tunnel Boring Australia. They did specialize in pipe jacking. And I'm not sure if you can see this here at the back. This is a truss wall. That's part of the design of the works. This in front, the white is the shield, and behind it, we have specific concrete jacking pipes coming. So few more. So there's in this shield, as we call it, there's an operator sitting. So if the ground is favorable, which is OTR or other than rock, he just digs it with a simple backhoe digger. And the good advantage of this methodology is he can see if there's any obstacles. I don't want to tell you what we've come across. We've come across cars, reinforced concrete, manholes, everything, even some bodies, but that's okay. I'm joking. Anything, this methodology we call open face pipe jacking. The operator can see what's going on. If there is a big boulder, for example, or something reinforced, we can cut it and pull it through the shield and through the tunnel that we have formed. This is the more complex machine. It's a German machine. And Herrenknecht is one of the leading manufacturers, but they are very expensive. The trouble with them is they don't have an open face. So if you put this cutting head for mixed ground condition and you come across hard rock, the only thing to do is dig it from the top, and that's the risk usually taken by the contractor. But there's new standards that are coming out. The owner of the asset is going to be taking on that risk now. So let's say in Queensland Department of Main Roads, if they're doing some tunnel under a road, if they agree to utilization of this machine and this machine can't go through it because there's a big steel obstacle there, well, they'll pay for whatever's done there and remove the machine and then try left or right. So geotechnical exploration, again, I cannot emphasize how important it is. This is like a long section. Basically, these are called earth pressure balance machine or slurry machines. They're more complex than the open face ones. The operator sits in this drill cab, and basically, while this is drilling towards the exit pit, you just add these pipes here. And there's here at the end, you can see this is the laser through which these can go up to 200, 250 meters. But those machines, they are steerable. To use, to do a 4.2 kilometer, like I explained before, you need a complex survey guidance system, but you also need intermediate jacking stations, because there's no way that you can push with these jacking frames 4.2 kilometers of pipe with all that pressure around it. So intermediate jacking station is something that is introduced every 100, 200 meters, and then you push that part of the tunnel and push the so those are very, very, very complex, and the mines and the oil and gas people can afford that. Here you wouldn't have application for that. I mean, in this city there is possibilities to put sewers and storm waters very deep, but a feasibility study needs to be done so that you can determine, or again, NCDC or Water PNG can decide whether it's needed. So I will send each one of you that, if you give me your email addresses, a copy of this. These advantages and disadvantages are basically what I've been talking. For open face is good for OTR. If you want to do rock, you have to have a rock cutting head. And then it is very important for the contractor not to go bust, to understand what type of rock we have. There are certain rocks that are very abrasive. For example, in Sydney lies on a thing called Hawkesbury sandstone. And while it's not very strong, 50, 60 UCS, it is very abrasive. So if you're in the business of microtunneling, pipe jacking, and you do not allow for that, you won't be in business for very long. So that's with the pipe jacking. The other most implemented trenchless technology is HDD. I'll be very, very brief on this one. Tony will have another little presentation, which he'll go in more detail. But basically, if you're trying to install a cable, you know, a HDPE pipe or a steel pipe for oil and gas, for water, and you come across a river or something like that, you do a pilot hole, then you attach a reamer, what they call, enlarge the hole, condition it, fill it with mud, and then you attach here the string of the pipe that you want to install, and you pull it back. And it requires great skills. So these are for bigger diameter, 400, 500, 600, 700. But this methodology can go in one go and can install your 63, 67, 75 mil fiber optic or cables. Tony will touch on that a little bit more detail. So this is an example of a HDD rig. The operator sits there. These are the drill pipes. You create the string, go there, and then it is also a big design task to understand how to pull the pipe back. The angle under which it sits on these pipe stands needs to be estimated so you don't damage the pipe. If it's steel pipe and you overbend it, well, it won't go through, to just break. So some of the lengths that are currently being achieved are going 3 kilometers, 4 kilometers. There's intersections happening. It is amazing. This is what is needed, I believe, to begin with for installation of conduits. You see you can install multiple conduits, or this is your HDPE pipe. It sits on rollers or pipe stands. Again, I'll let Tony do a little bit of chat on that more. This is a big HDD spread. You see it's made of part of it, it's we do a lot of recycling. Just giving you an idea, so it can go under these kind of hills that can go 1.2 kilometers to, diameters 1 meter, and it is applicable for gas, for oil pipeline, for slurry pipelines. But it's not cheap. The design engineer needs to do his stuff. But if this is a hill that is, 300 meters high, how are you going to digging that is often, much more expensive than doing this. So it's an estimate that the design engineer needs to do it, and usually the HDD contracts in America, they are separated from the pipeline contracts. So the owner, I don't know, Total or ExxonMobil, if they've got a pipeline of 50 kilometers and there are certain areas under high, mountains or rivers that need to be crossed, you definitely cannot lay the pipe on a river. It'll just get damaged within a year or so. So you need to bury it under the river, and this is been going around the world since the mid-90s with this methodology. So you can get an idea how it is. This is the entry of the pipe, and the pipe sits on rollers here, and basically once you have dug that pilot hole and enlarge the hole, you then go into the operation of pulling the pipe. That is a very complex and crucial part, and everything stops until the pipe is pulled into the hole. While you're pulling the pipe, all the mud gets disposed on the other side, so you've got to get rid of that through recycling and continuous, otherwise, again, great skills are needed, in particularly with entering and exiting on this methodology, so that cracking doesn't happen or bursting of the ground conditions. So sometimes even the first 20 meters should be cased. This I wanted to show you a project. This happened back in 2001. So in Australia, for example, if you want to bring a pipe from the ocean, sometimes, if you can imagine, if you've got a gas field somewhere there and you want to bring the pipe to sea, you cannot open cut the beach. This in front of me was a sacred Aboriginal Billabong Creek. Above that was a 100-meter sand dune. So no authority in Australia whether it's the local council, whether it's the Environmental Protection Agency, will let you dig through dust. So the way that shore approaches are done is, you have a big pipe laying barge somewhere here on the horizon, and you do a bore, and then you pull the pipe with a pipe barge, with the assistance of the pipe barge that's sitting there. This was a great innovation. We call this forward trusting methodology. So we told the client, and the client was an Austrian oil and gas company, which was called OMV, which is equivalent to Kumu Petroleum here, for example, the national oil and gas company. We told them that we will eliminate the need for the barge. So the barge, the pipe laying barge is very expensive. The LDs for that, liquid damages, then 20 something years ago cost about $500,000 a day. So if you're late with your drilling, you're exposed to that. So this was a company called Cherrington, Australia, and I've got like a little 5-minute clip. I'll show you that. They were the pioneers of this methodology. So basically, he designed this rig, which you bore, you condition the bore, they're ready, full of mud, and then you push the pipe, which is sitting on this side on the bore, without the need of a pipe laying barge. So basically, that's the forward trusting rig. And if you can see, there's pipe laying holding here. You got to determine carefully the angle under which the pipe goes into the rig. If you miscalculate that, there's a lot of problems there. This was the rig, and this is what the client gets at the end. So he can join these two pipelines, and they can go to the plant processing facility. Again, there's a lot of advantages and disadvantages that are associated with each method. HDD is generally more cost effective, but there's disadvantages like the borehole that you're doing is not supported by casing, for example. So you again need skilled personnel to know at which angle to go in, the speed, the size of the bore. So, for example, if you're drilling through rock, you don't need that big size of the bore to accept the carrier pipe. If you're drilling through other than rock, clay, you need to have a bigger diameter bore. Another trenchless methodologies is a pipe rehabilitation. I'm going to try to share a little basically it's a trenchless technique that rehabilitates the damaged pipe using a flexible lining material. You insert, I'm not sure if we're back, you insert the material into the manhole and then that and takes the shape of the pipe. I'm just going to 10 seconds. Can you see the? This is not working. Is it showing up? Just have a look at this. sharing this. If it's in Reddit, share. I'll let you guys see it there. Oh. Okay. Do you want me to go back to that? I'm just going to play the audience in the class. Sure, can you hear the voice? No? It was just a short clip of restoration of pipeline using that that was just a short. You just, I'll play it one final time to get an idea. Basically, you insert this resin inside a manhole, and then it takes the shape of the pipeline that's damaged. Back to normal, yeah. One of the other methodologies is the pipe ramming. But like I said, it's very basic. It's pneumatic hammer just going through a receiving pit. It's not that common anymore. So it's one less favorable because you can't achieve precision, but it's suitable for short distances and not critical infrastructure. I wanted to get your attention on steel segmental shafts. This is not a trenchless methodology as such, but it's a method that was developed some 15 years based on an idea that we at Tunnel Boring Australia we had. It's a shoring system that is used for launch and retrieval pits. It's a steel segmental shaft, and I'm just going to go through some photos, and you will all understand it. Hopefully, it's very, very effective and very, very engineering, applicable in areas that have got ground conditions that are other than rock. So basically, you have a 4, 5, or 6 meter diameter cutting edge, which is put in a hole, and this is about 1.2 meter deep, and you leave this trench for the truss ring that we need to do later on. The truss ring, the steel, and the strength of the cement is again designed depending on the ground conditions, the depth, and the diameter of the bore. Once this is placed on these stands here that you can see, we put 4 gallows or jacking ramps with which we push these 1.2 meter segments. As you can see, that's the second 1.2 meter, and each circle is made of 4 or 6. They're different designs. The excavation is done by a telescopic excavator, and you excavate something in the middle and then push. It's a very effective excavation methodology, and it's used not just for launch and retrieval pits, but it's used as a shoring system, because with this you can go 20, 30, 40 meters. It's very difficult to do a 20, 30 meter rectangular excavation, and it was perfectly designed. It's a controlled sinking of the shaft. There's a platform where the laborer sits, stands, and you advance. In this case, we came on top of a 100-year-old brick sewer tunnel. This is in Brisbane, as part of the Airport Link project, somewhere 2015. And our job was from this side push another sewer pipe into this existing tunnel. So we dug on top of it, and then we bored from another location into here. So complex, but very satisfying. And it was the only solution because we had to put this pipe, and it went under 4 or 5 houses. Otherwise, you wouldn't have been able to do it. That was the only type design available at that stage. So the good thing about these steel segmental shafts is once you've done your microtunneling or pipe jacking, you can build a manhole. And the steel segmental shaft around it, once you have finished building the manhole, you can pull out. It's like pulling a knife out of butter. So it's very effective shoring system, if you like it. And this was a project at Wollongabba on behalf of Can you hear me? Am I online back again?
Yes, we can hear you now.
Thank you. This was the design drawing. This is where the engineer comes and designs. I haven't mentioned, but in all these pipe jacking technologies, it is always useful to know that you need to drill from downhill towards uphill. Otherwise, if you drill downhill, all the fine cuttings will go to the head and you will have problems. So this here was the area which was subject to flooding, and they decided they needed 3 tunnels under these 5 railway lines. The pit needs to be designed accordingly. For example, the trust wall, you need to work out what would be the maximum pressure force that you will get there. At the end, we ended up, they did recalculate the hydro. No. Sure, if I can be heard. Like I said, picture explains everything. So this is that jacking rig. I just want to draw your attention on something. This is the pipe that we use there. And the pipe that you use in most of lifting. So to lift a concrete jacking pipe, you need probably a larger crane and a 20-ton excavator. These are about a third of the weight of a normal jacking pipe because the wall thickness is only 70 mil, and the name GRP says it's glass reinforced jacking pipe. So this is a 2100 pipe that came all the way from Austria. We do manufacture it now. Another example of the trenchless methodologies is replacing of existing damaged culverts. So this is under the Bruce Highway somewhere. Queensland Department of Main Roads was a main client for us. And basically by utilizing the shield, you replace, once upon a time, somebody sold a lot of
speaking if you understand.
So when you have multiple pipes in one culvert, you need to determine what is the space from the outer wall between these two pipes. Otherwise, you'll have a sand effect. So there's a lot that goes into the design. It's a very short time frame that we've got to address everything, but you need to know the cover, you need to know the distance between multiple pipes. And then once you have installed this, from inside, we grout the pipes so that, you know, but this is the damage that can be caused in these corrugated steel pipes. You see, that's the condition of that one. That's the condition of the new one that we had once we replaced it, and this is a new one. So when this happens, you see, that's the corrosion that you have. Once this starts happening, the road above starts to collapse, and you have to bring in Department of Main Road or whoever looks after the road every 6 months to fill the top. And they decided they're going to have a massive action. So we have replaced thousands of these only in the area of Southeast Queensland and a little bit higher up to Harvey Bay. I mean, when I say we, these are companies like Tunnel Boring Australia, Pesimenti Australia. So that is the funny part is that this corrugated steel pipe was sold to the authorities by a company called Humes, and now they're selling them the concrete pipes, which is good business. This is what it looks inside. This is a good friend of mine who knows how it is, how to operate these machines. Basically, we call this a can opener. So you go inside from one side of the steel corrugated pipe, you cut a segment of 200 or 300 millimeters, pull out the corrugated steel pipe, and then push against it concrete pipe. So it's all the time protected. I'm not sure if you all recognize this. This is your Cocky 2 Mile Road in Port Moresby. It caught my attention. And it's a difficult ground condition, difficult construction. Here in this part, you can see there's a little collapse. You had a void, and I'm not sure if Lazaro was here, he would have told me, but Murphy's telling me that this has been, but I'm just going to give you an example, and then I'm going to tie it to an example in Australia. This was the culvert, and it went to the middle of the road, and this is where the water gets in here and comes out of here. But because of the damaged culvert, you had this void forming here. And with every rain, this void is always bigger. You see, this part of the road was blocked. And these are photos that were supplied to me by Lazaro Hemmetsberger. So your culvert there is getting damaged with every rain. This void under the road gets bigger and bigger and bigger. And one of these days, if it hasn't been fixed, but I'm sure that it has been, a big truck or a car will just drop in there. In Australia, in the Central Coast, there was a situation where a family of 4 was killed because of something like this. This is 20 years ago. Since then, all culverts are subject to rigorous inspection and condition checking, and so this was a dangerous thing, and this is what prompted me and Lazaro and Solomon here to talk about. This is one way it can be resolved. You can just realign this pipe, or just install a pipe to the center of the pit with an otherwise, I don't know how you fix this other than filling it with concrete. But then what do you do with the rain? I'm not sure. Couple of useful links. This is the Australian Society for Trenchless Technology, and it's a big industry. The next exhibition happens on the 22nd and 21st of July next year. Every young engineer, every civil contractor that wants to know something more about this should go to these places. I'm going to your Expo, Industrial and Mining Resources. I was there last year, I was there this year, and I'll continue going there. But if you really want to see how big the industry is in Australia, make your employer send you for your CPBs down in Sydney in July next year. July next year is going to come very quickly. Come see, there's a lot of consultants, a lot of contractors, a lot of suppliers, people from all four corners of the world come. You can see backtracks, you can see drilling machines, you can see Chinese machines, you can see German machines, and you can talk to a lot of experts. A lot of councils, a lot of water authorities, railway authorities, they all attend there. And it's still not, you know, a very well-known part of the civil industry in Australia. There's a lot of people don't know anything about it, you know, so they go to people that have been working in it. There's specialized consultants, like I'm only a smaller company, but there's bigger ones, BAMSR, Trenchless Advisor, Future-Proof, and things like that. And they try to specialize in everything. We have a group of people that specialize. You need a proper design to be done to determine the type of methodology, to determine the pipe length. Sometimes every situation is different. This one, like Kokituma Road, you need to look at it carefully. We couldn't even determine what's on the other side of the road. Didn't even know who's the owner there, so that we could make a case for water PLG. But then later on, I was told that it was resolved. So, but that's just an example. You have a lot of cases like this, not just here, in Ley, in every accident. And in the mines, there's a lot of application, as you could see, there's stormwater tunnels and anything like that. Tony, do you want to do something about AHDD? I can be back for questions if there's any questions, but I'll just let Tony do. Okay.
Put that laptop here. You don't need that. Thinking that one is needed. This one.
Morning, everybody. My name's Anthony Crane. Thank you all for coming. It's really good to see some good numbers here today, and obviously the online people as well. We really appreciate taking the time to come and have a look at this this particular methodology that Dim Shay's been involved with and I've been involved with. Just a little bit of background. I've been in the mining industry for over 10 years and the HDD for 27 years now. And then the main point that I remember is my oldest son was born the year that I went to work for a drilling company in the HDD, and he's 27 now. So that's how he's like the years just get away from you. They really do. Just spent a couple of months up at the Hidden Valley Gold Mine working for Harmony, doing some TSF geotechnical investigation work. So that's been a different scope for me for the last sort of 9-10 months. It's been very, and that was the first time I came to PNG and really embraced your culture and how you guys, as we all are, continuing to learn. So just a bit about, I worked for this company 2018 to 2021, the Trenchless advisor, and as you may or may not be aware, Australia rolled out a fibre optic network to basically all the regional towns, all the metro throughout Australia, and some of the remote areas have got access via satellites, but basically in Sydney, Melbourne, Brisbane, Adelaide, Perth, everybody has optic fibre going to their house now, so they have a very good connection. Now, a lot of that work has been done using machines, not so much this maxi rig, because that's quite large, but definitely these smaller Vermeer, Ditch Witch, what they call a 20,000 pound or a 30,000, 40,000 pound. These can fit on footpaths in people's front yards and drill all the way down the street. And we can come to the surface, drop pits in over the conduit between each house boundary. So traditionally, trenching was one of the only methods before directional drilling was introduced. So open trenches, excavators, trenching machines, vibe plows, which basically puts an optic fibre cable or a copper cable directly into the ground. So that's been around for a long time. So open trenching works really well where you don't have concrete driveways to worry about. There's minimal existing buried services, your gas, your power, your existing communication cables, and also where the ground conditions are quite stable and not running sand or water charged ground conditions, and even rock. I mean, excavators, hammers, you can hammer out a trench with rock. It just takes a bit longer, that's all. So trenching works really well in your greenfield areas, which is your brand new areas. Benefits is you can visually witness and check the construction, incorporate the most preferred backfill material. Sometimes what you take out of the ground is not suitable to go back in, and that's why you end up with your subsidence. And the ease of connections, easier to work on, and you can install most pipes these days, steel, plastic, PE, during your open trenching. But some of the issues with open trenching is that crossing of hard surfaces. So you've got your roads, your bitumen, your freeways, your rivers, your creeks. There might be a retaining wall that separates where you want to get your conduit between 2 points. And existing buried services can be an issue. If there's a lot of existing services, open trenching becomes quite dangerous. You can damage those services. Like I said before, sandy, wet or rocky ground conditions, and reinstatement requirements. So I was involved in that NBN construction, worked for a tier one contractor by the name of Downer in Australia. And one of our biggest problems with our trenching and grunder matting was reinstatement. We were basically coming back 4, 5, 6, 7 times to replace people's driveways, continually top up the trench with topsoil and grass, because the residents would complain that, you know, after rain, the subsidence was there. So our contractors would basically do the job 4 or 5 times. So NBN become aware of the drilling, the HDD services. So they went down that pathway of let's try and minimise the open cut trenching and utilise the HDD. So we ended up doing a lot more conduits underground using that directional drilling machines. This is where it kicks in here. So there's different methods. There's the augers that you can use on a small machine to go underneath people's driveways. That's a big air hammer. That's something that Jim Shea touched on earlier. These are pipe jacking machines, and there's your directional drill on that right-hand side. So they're surface launched, basically sit on the surface, as opposed to your pit launched machines, which is your microtunneling, auger boring, the ramming, the pneumatic piercing, and the horizontal directional drilling. Like I said, it'll sit on the surface. I have been involved in projects where we've had to dig the machine into below ground, just because of the profile of what we were achieving for the client. So we've done that before. We've excavated, we've benched and battered down up to 10 metres and put the machine down. It's still done a directional bore, but it has been on the surface. And there's been contractors that have actually modified their directional drills so that the rail, the actual drilling component, is down there, and all the power pack and the engines are up on top. But that's a fairly extensive process to do that. The benefits of the trenchless is minimal disturbance to all surfaces. Long open trenches, generally we're steering away from that. Like I said, coming back and reinstating multiple times, just costing everybody too much money. The HDD is suitable for construction in most ground conditions, and there's minimal reinstatement requirements. So basically have an entry point and an exit point, and that's all you need to restore. Everything in between that hasn't been disturbed stays as it was. It's now the preferred method for main roads in Queensland, Queensland Rail, and anywhere where there's a waterway. They're not allowing open trenching through waterways anymore. It's all going to be done with trenchless technology. Visually appealing during construction, minimal disruption to traffic and pedestrians, and can be very cost and time effective if used in the correct environment. Here's a little bit about, like I said, surface launch machine. The drills basically do a radial curve and a horizontal, and they are horizontal to the ground surface. The drill head, which I have some slides of, it is steerable. It's based on a wedge-shaped drill bit, and when it sits in a particular position, if you rotate it, it will spin in. But if you have it at what we call 12 o'clock, it will force its way through the ground and come to the surface. So when we start a drill shot, we have it at 6 o'clock, and it forces itself down into the ground. But sort of explain it to some people, a typical door wedge that you put under the door to stop it slamming shut when it's windy, that's what they sort of shape like. It has a bevel. So yeah, they have a transmitter inside the drill head, and then there's a receiver locator box which you can basically walk over the drill head, the sonde housing, and you know exactly how deep it is, what direction it's going in, and what pitch you're at all the time. It's a live feedback from the transmitter to the receiver. Another part of the process is the drilling additives, which is your muds. Very similar to the oil and gas with the getting the cuttings out of the hole. It's the same principle, bringing it back out the hole to keep the hole clean. This is a design that is used a lot. There's different software available these days. This is an older version of what I had. I was running the Vermeer bore aid system, which is software that you can purchase through the bore aid website. But this is basically how you can do all your calculations. You can give it a lot of information and it will give you a preferred bore path, but you can edit and change your bore path to suit. So these things are great because this is a typical railway corridor. Now in Queensland, they won't allow any conduits to be anything below about 3.5, 4 metres. So every time we did a rail crossing, we had to be 4 metres below the rail so that there was minimal disturbance and 90% of the time, zero impact to the rail line. Sometimes if the drillers were using incorrect mud or trying to go too quick, it would heave the ground and the rail line would lift. They had to shut the rail down for sometimes weeks to repair the line. So they come up with their standard. QR have got a rail standard. Main roads have a main road standard for directional drilling. And it's all about having sufficient cover below their infrastructure. So the beauty of these programs that we've been using is you can also put in services. So over here we have a 150 millimetre sewer main. There's a 525. So you can plot your existing services into this software and you can change your design around so that you've got clearance from those services. And basically, you're not going to hit them. But you do have to go to site and find those services and have a surveyor come with you. So when you do pothole, you basically pothole down on these sewer mains to verify that they are at a certain depth and verify their alignment. You record that data, you put it into this system, and we just use the basic RL system in Australia, which is your elevation above sea level. So you can capture what depth these services are at, and then as you do your profile, you can make sure that the bore, if it crosses below it or above it, you're going to have some clearance. And a lot of the time, sometimes you have to make the bore longer or shorter to maximise your clearance from some of these services. APA gas in Australia, some of the utility owners for the water infrastructure, they will actually, when you do a die before you dig search, they will inform you that they require a minimum of 1 metre away from their service at all times. And if you physically can't maintain that metre, well, then they'll have somebody on site to ensure that there's no impact to their infrastructure. So yeah, typically pre-planning is a major part of any project, and that's gathering as much information about the site. Geotechnical plays a huge part. A lot of the time you can't get it, but some of the bigger projects I've been involved in, that's one of the first things that the client will organise is the geotech. They will do the vertical hole to give us a breakdown of what that ground condition is like, and it allows us to then look at the best elevation depending on what sort of pipe you're putting in. Sometimes up near the surface it's unstable, and if you're down too deep it might be 200 MPa rock. So you're looking for that window where you've got good ground support, your drill fluids are going to remove all the cuttings out of the hole, and it's going to support the hole at all times. That's the worst thing is putting it in a ground condition that's not suitable, and it's going to give you problems down the track. So we do a lot of pre-planning, on-site documentation. Correct equipment selection is another big part of making sure that your project's going to run successfully, and then looking at your location setups. The bigger the machine, the more room they need, the bigger the spread. There's usually larger trucks, tooling containers, basic sites these days. You know, we're setting up areas for the guys to have their lunch. There's a toilet on site. So the NBN project was different because they were moving down the streets every day. So they were just on the move the whole time. Some of the boys on the NBN project would drill 400 to 500 metres of conduit a day. Basically a 50 mil, 63 mil conduit, which was big enough for their fibre. Every now and then they put in a road crossing, which would be 100 mil. But yeah, they would get through a couple of 100 metres a day. I was involved in a rail project over 10 years ago in southern New South Wales, and New South Wales Rail were running optic fibre between all their platforms over hundreds and hundreds of kilometres. So we were installing 63 mil, no, it was 32 mil subduct down the rail corridor. We were doing 400 metres of drilling per day. There was good ground conditions, very good ground conditions. There was areas in the Southern Highlands that was a lot of sandstone, but we were still managing to do 100 metres of rock drilling per day with the right machinery. So yeah, part of the preparation is also finding good drilling contractors that are competent, confirmation of their skills. Probably the last 10 or 15 years, the government's been involved in upskilling all our HDD guys. There's all certificates I think there are up to about 40 or 50 certificates now for this industry. And it's as simple as reading plans, communicating on site, obviously your excavator, your backhoe, your drilling. There's a ticket now for drilling. There's the ticket for drilling fluids, mixing fluids, understanding how the fluids work. Yeah, it's the guys are getting very good skills now. Every bore that I've ever been involved in has always been considered as site-specific. Every design must be practical and achievable. That's the whole purpose of the pre-planning, is to go out and go, well, yes, I could do this, or you know what, it's not suitable for HDD. It might be suitable for microtunneling. Set it up with 2 shafts and do it that way. Yeah. There's always a way. It's just finding the most not profitable, but most cost-effective and safest way of doing something. All designs must include a safety in design approach, understanding all the risks and issues. Never assume one bore is the same as another. Correct pre-site investigation and planning is very, very important. And like I said, engaging a contractor who has the correct skill set to succeed in the job. We do a lot of project monitoring and management. Over the last few years, both Tim Shane and I have been called in to some tier 1 projects to be superintendents, just to ensure that the contractors are doing the right things, remaining compliant, their paperwork and their methodology, and so that's been quite good for us to get to see how most of these guys are operating out in the field. So achieving successful HDD, like I said, 1, project requirements, in-house design, cost and method selection. Investigation is very, very important with your risk, achievability, and then come up with a bore plan. Sometimes your bore plan can be a preliminary plan. You can test the model, go to site, think, you know what, I need to make a couple of changes before you basically do a issued for construction bore plan. Ensure that your contractor has got all their on-site documents and equipment. Construction setup, drilling, pipe installation, and then your demo and verification that the job's been done to a particular standard or to the client's satisfaction. And then, yeah, project completion. This is it's a 20,000 pound machine. So this machine was most commonly used on the NBN rollout in Australia, all over Australia. and the one beside it is a maxi rig. That's a Vermeer 330 directional drill, which is capable of drilling 2 kilometres, 3 kilometres in length at depths of 50 to 60 metres, and then pulling back a pipe that's a metre diameter. A lot of contractors in Australia that have been in the game for 20 to 30 years are running these rigs now. They've gone from that 20 years ago, and they're now running maxi rigs. This is some of the equipment. That's obviously the small rig again there. So it fits on a small truck. You've got your mixing tank, quite sufficient. This is the vacuum truck, which you do your potholing with, and it also serves another purpose where when you excavate your little holes for your drill to go into the ground, it fills with mud, fills with the drilling mud. You can suck it up with your vac truck and then take it to a waste disposal. Or, depending on the ground conditions, your mud can be put through one of these recycling systems. So it basically recycles your drilling fluids, very cost effective, so you're not throwing good money down the drain. And these things will remove all the sand, all the rock, all the spoil that you don't want back down the hole, and it'll pump that'll pump your fluid back to your drill rig, so it can go back down the hole again. This is the tracking equipment. So the drill operator has this particular screen on the drill rig. This long cylinder is the actual sonde, the sonde housing. So it's transmitting, it's a beacon, it's transmitting, as soon as you activate it with your batteries and you turn your box on, it's transmitting a signal up to the surface. And this F5 Falcon is what picks up that signal. Gives you your depth, gives you the temperature of the drill head, gives you your pitch. We generally, when the drill head enters the ground, it's around about -20, -25 degrees. And like I said before, if you roll around to 12 o'clock, after you've gone in, say 1 or 2 rods, and you start pushing your drill head, it'll start climbing, and it'll go from -20, -18, -15. Every time you come up 1 point on a 3-metre rod, you're gaining 30 mil. So if I was at -10 and I pushed the drill rod to come back to 0, it would come up 300 mil. It would deviate through the ground by 300 mil. And then if I went to +10, it'll continue to rise at 300 mil per 3 metres. We generally like to, when we do a design, we don't try and do steers like that. We just try and do minimal steering. It's better on the machinery, better on the drill rods. So I try and average a bore path using a 1 or 2% gradient, so that you've got everything nice and gentle. If you have a lot of steep angles in your borehole, it makes it harder to pull the pipe back through with friction. So we try and keep it as easy as possible for everybody. And it works. You know, if you've got a plan, you do a plan up, you've got the right grades, especially with the larger diameter pipes, you can't put them under too much stress. This particular photo shows that's the drilling muds, which is the bentonite coming back out. Now this particular hole has a steel pipe. I'd say that the ground condition was quite soft at the entry point, so sometimes the guys will push a steel casing in, which is larger than the drill head itself, and that just helps guide the drill head. This will be a job where they probably remove that, and they'll expand the hole out bigger and bigger for a large pipe. It also helps to minimise the frack out. A frack out is basically where the borehole pressure has exceeded the ground's ability to contain it. It'll come up through fractures in the ground. Sometimes it's due to the guys running too much pressure when they're drilling, so they've got to monitor that all the time. This is the tooling. That's that typical drill head that I was explaining before. Carbide bits on the front. That's most commonly used in OTR, and you can also drill in shale. The boys also can drill, I'm going to say, anything under about 40 MPa rock. These things will get through. You will wear them down. You can damage them, but you can do a lot of soft rock with that railhead there. These are electrical conduits with the pulling heads on them. That's a multi-way there, so that all those pipes can come back through the same hole. This is a reamer, what they call a reamer, so that upsizes the hole. And there's a typical spread of drill pipe. Now that's off a larger rig. I can tell by the size of the threads that they look like they're 7 or 8. That's a maxi rig photo of those drill rods. So these are your drill bit types. You've got your conventional, that's very good in sand. You can get a lot of steering capabilities in sand. That's another conventional bit, but it's got tungsten carbide bits on the front. So if it gets a little bit crunchy, you can whack one of them on. These are all interplaceable. That's the Tri-Hawk there, which is very, very common. These PCDs, this is where you start to get into the expensive part of the market, but these PCDs will drill sandstone. And a good PCD bit, you'll be able to, generally the guys are getting at least 1 kilometre, if not 2 kilometres before they need to be replaced. But they are anything from 8,000 to 15,000 Australian dollars per drill bit. These are your tricones. These are used a lot in mining as well. And the tricones are, again, they're quite expensive. But if you treat them with a bit of respect and try not push them too fast, you'll get good life out of a tricone. There's also air hammers that are set up. They'll drill rock. They'll drill extremely hard rock. I haven't had a lot to do with air hammering, but I've got some colleagues that have done it. It's another successful way of getting through difficult ground conditions. So yeah, here's a bit of a breakdown. Your conventional bits are good in your sand and your clays. The conventional with the tungsten carbide, they'll do sand, clays and shale. And then your Tri-Hawk is, yeah, down to, like I said, your soft rock, less than 50 MPa. PCD, soft and hard. PCD is, if you try and put that through ironstone, blue metal, you'll destroy it. They're more designed for the sandstone type rock faces. Whereas the tricones, you can run them in pretty much all conditions, but they're also best suited for your hard metal rock. And then the air hammer, which, like I said, it's for really hard, extreme MPa rock. So the risks and limitations So, yeah, right. Yeah, as I was saying, these are some of the risks, potential risks with anything, any job with direction drilling. Is you got your heaving of the surface, you got your frac out where your liquid comes to the top, and services that may have not been identified at the time, or they're just at incorrect, they were recorded at incorrect depths. So, and that can be a regular occurrence with services. One of the biggest risks is the client will say, look, we've had a locations expert come to site and he's been able to identify A, B, C, D, but there's still a couple that are showing up on his radar unit that he's not sure where they are and how deep they are. So sometimes that involves another day or two of potholing with a back truck to try and identify where those particular services are. This is a potential risk with your design, as I was saying, excessive bend radius, to keep it short, as opposed to making it a little bit longer with the correct bend radius and still avoiding all the services. You'd find that depending on what size diameter pipe, usually at this point in the bore is where the pullback pressures start to rise. So the gentler the arc, the better off you are, and especially below a river. That can increase the frac out chances of putting fluid back into that creek there as well, just because it's not an ideal bend radius. Yeah, once again, set up locations. This is the whole point of doing all the pre-planning. If your setup is too close to an existing service, you can see that it gets very close to that particular service, which being orange, it's probably electrical. I always try and give myself plenty of room, so set back a bit further. That way you've got more time to have a safer clearance with your setup angle. This is a street setup. This is like an NBN setup. You got all your houses, got your drill truck, that's your drill rig, entry pit, and that's your bore path that's going across two driveways, possibly a third driveway with an exit pit. These guys with the smaller drills, they've got the ability to hit the ground, come back up the next boundary to around 700, and then go back down to the next boundary, come up. That's where I put the optic fibre pits over the conduit. Trees, there's a lot of regulation around trees all throughout Australia. Basically, don't disturb the tree root system. So once again, your client might say, look, we just need to get past the tree, but setting up too close to the tree, you can end up going through the root system. That tree may fall over in 12 months' time if you damage the roots. So once again, just by having a bit of thought and a bit more room, you can go back a bit further, ensure you've got a better clearance below the root system. HDD problems and issues. Most construction projects can have some kind of problem or an issue. That's obviously quite a big problem with a crane that looks like it's about to tip over. And even when you're on your weekends, you can have issues with your toys. So yeah, Trenchless is no different. That's a pretty bad frac out, that one there. That is a conduit that's been damaged by an excavator by the looks of that. There's some electrical cables that have been damaged, and that's an example of the ground heaving. So with proper planning, understanding the construction methods, practical and feasible design, competent contractors with experienced capabilities and machinery, ensuring both your client and your contractor understand all the risks and issues, and some monitoring. It can be a very successful way to install infrastructure. I'm talking water, gas, communications, sewage, not so much stormwater. It's more concrete. The stormwater is more aligned to the microtunneling, depending on the diameter of it. But in saying that, if it's a HDPE pipe, there's no reason that stormwater can't be utilised as well. Some other issues and problems, existing utility strikes, unachievable bore designs. Sometimes there's just situations where you can't achieve a safe bore design and the bore construction. Failed or collapsed boreholes, unacceptable product pipe. Sometimes the guys will receive conduit that has an issue with it, so they're generally advised not to use it. You got your frac outs, your ground heaving, incorrect bore location. Sometimes that can be let down to the fact that your beacon. Sometimes those beacons, if you allow them to get hot, I think it's 72 degrees or 82 degrees. If your drilling fluid is finding another pathway, and sometimes that pathway can go 200 or 300 metres, but you basically got a dry hole when you're rotating, that drill head will get really, really hot. But your monitor system will tell you that it's heating up. If you get it to a certain degree, it basically cooks that sond. A lot of guys don't realise, and they'll use it again, and they'll think they're drilling here, and they actually find out they're actually drilling over there because their sond's not working efficiently. So you got to keep an eye on the temperature on it. So yeah, along with a lot of other things, a lot of the risk minimisation solutions are understanding the Trenchless method that you need, undertaking a proper site investigation. That's a key part of the whole process is a proper site investigation. I call it a feasibility study, which involves the geotech, finding out where all the services are, finding out what I can do with certain size machines, and then coming up with a design, and then providing detailed on-site documentation as well. Monitoring of the contractors. We have like Dim Shay mentioned earlier, we've got access to a lot of other independent consultants in this industry. There's always solutions to constraints. So we have a network of people that we regularly communicate with. We do quite a few projects where ITPs are part of the project. That's an inspection and test point. So it's basically a checklist as the project's progressing through. We like the guys to be able to show us that they've got everything on site they need. The documentation's up to scratch. They've done the pilot bore. We make sure there hasn't been any frac out. So yeah, we're basically doing an inspection and a test point, hold point, and then it goes to the next phase of the job, just to make sure it's running okay and there's no issues. If there's any issues, you can pull them up and say, hey, we've got to fix this before you go any further. The whole point of an ITP. Request a borehole plan and methodology from the contractor before he works, So yeah, sometimes I would go and do all this feasibility work for one of the tier ones. They'd come up with we do a design, a preliminary design. They'd put it out to put it out to the drilling contractors. They would then also provide us or the client with a bore design, which we look at and sign off on. There's a lot of consultation goes into into HDD, especially with the larger projects. Incident reviews, we're quite capable of doing that. This was a power strike on a bore length that was 105 metres long. There was 4 of those 140 orange conduits going through. So the diameter of the hole was 340 mil. The borehole needed to, 4 140 conduits. The bundle diameter was 340, so the minimum borehole required was 450 mil. So the problem, the issue was it hit the existing electrical cables, which unknown location of electrical cables under the road. Clearances used between utility and final borehole needed to be analysed further. But yeah, once again, if you can't find something, especially when it comes to power, I wouldn't be drilling underneath it or on top of it. I'd rather find it. Standard projects for work being undertaken for the client, install conduits over the required distance of 105 under a residential road with a single bore, limited monitoring. So there was basically none for HDD specific of the contractor that was undertaking the work at the time. So it would have been quite costly. Equipment used on the site was suitable. All done before you dig plans, which is they're quite good now. They're quite detailed. I don't know if you guys have a similar platform here in Moresby that basically, if you're a trenching contractor or a drilling contractor, you can get plans of where all your communication and your water and your sewer. We have access to all that. It's quite good now that there's an app that you can get on your phone and you can physically look at the plans on your phone. So yeah, unfortunately these guys did pothole on the road to find those power conduits. They've only assumed the depth of the cable because they observed it in the pit on either side. Generally, if there's power conduits in pits beside the road that might be 800 deep, there's a good chance they're going to be 1.2 or 1.5 underneath the road. That's just a bit more about the dynamics of that incident. Shows the borehole and the strike. That's a photo of it there. He's actually smashed through the existing conduit network. So solutions to that particular problem were, ensuring locating of all existing utilities are known. Always assume a bore under a hard surface is deeper than a trench component of the network, which it always is. Both the driller and the project manager should discuss the proposed bore path plan and issues before continuing. So yeah, suitable clearances should be used when utilities are sited or unsited. And both the contractor and client should understand the issues and share the risks, notify client of possible risks, and if there is a risk, minimise it. And that's basically it. Any questions from you guys?